This is 5 Minute Friday on Code Llama. Welcome back to the Super Data Science Podcast. I'm your host, Jon Krohn. Today's episode is all about Code Llama, a model with its weights recently released to the public by Meta. Code Llama is a large language model derived from Llama 2, which I detailed back in episode number 702. One of my few criticisms of Llama 2 back in episode 702 was that it didn't handle coding tasks nearly as well as it did tasks that involved natural language only. Well, that's exactly the gap that Code Llama was designed to fill. This means that Code Llama has the potential to revolutionize how we code by making workflows faster and more efficient for data scientists and other folks who write software. And like Llama 2, Code Llama is free for both research and commercial use. All you have to do is fill out a super short access request form, which I've provided in the show notes at superdatascience.com/712. All right, so what's up with this Code Llama? How is it different from Llama 2? Well, starting with Llama 2, Meta performed additional training on 500 billion tokens of code, 500 billion tokens of code and related data. They also performed something called infilling code training that specifically allows the LLM to excel at filling in gaps in code. The result is that you can provide a text prompt to Code Llama like, provide me with a neural network in PyTorch that's appropriate for an object detection task. And Code Llama will generate appropriate code for you automatically. The code data are quite diverse, so Code Llama can be used for code completion, debugging, and more in a wide range of programming languages, including Python, C++, Java, JavaScript, Bash, and a bunch of others. Not only that, but like Llama 2, Meta have released a range of model sizes for Code Llama. Specifically, Code Llama comes in 7 billion, 13 billion, and 34 billion parameter versions. The largest, the 34B model, provides the best coding assistance, while either of the two smaller models can fit on a single GPU, and so therefore offer lower latency in real-time applications. Being able to choose between these three model sizes means that you have the flexibility to choose your model size to weigh performance, cost, and inference time trade-offs for your particular use case. There's even more optionality than model size, however, because Meta also released specialized Code Llama versions. Because Python is so critical to AI research and development, Meta trained their aptly named Code Llama Python variants on an additional 100 billion tokens of Python code. And separately, their Code Llama Instruct variants were instruction fine-tuned on 5 billion tokens of natural language instructions and the expected outputs. Like the general Code Llama family, the specialized Code Llama Python and Code Llama Instruct variants come in 7B, 13B, and 34B parameter sizes. All in all, that means that this release involves a total of 9 models: the general Code Llama family, the Code Llama Python family, and the Code Llama Instruct family, each of which has 3 model sizes. So in this episode, I've already covered why you might choose one model size over another, but what about a particular variant? Well, you might go with the Code Llama Python if you know your use case involves Python code exclusively. And Meta themselves recommend that for natural language applications, you use a Code Llama Instruct variant because these are better at understanding what humans expect out of prompts and are also aligned, meaning that the Code Llama Instruct variants are fine-tuned to generate safe and helpful answers in natural language. Cool. So as you can always expect with a big splashy release like this, the Code Llama authors have, of course, compared all 9 Code Llama versions against the major proprietary models that handle code well, such as OpenAI's Codex, GPT 3.5, and GPT-4 models, as well as against the major open source models that handle code well, such as StarCoder and the 70 billion parameter Llama 2. At a tenth of the size, even the 7B Code Llama outperforms the 70B Llama 2 on the majority of the coding benchmarks Meta published. The largest Code Llama, the 34 billion parameter version, comfortably outperforms all the open source alternatives and performs comparably to GPT 3.5. The only model Meta shows outperforming their Code Llama is the mighty GPT-4, which actually outdoes Code Llama, even Code Llama 34B, by quite a ways. Well, super impressive overall, but of course, all of these results should be taken with a grain of salt since Meta published them themselves. The best way to confirm Code Llama actually is a game changer for your code generation use case is to experiment with it yourself. With Code Llama, you could now build powerful Copilot like tools yourself, but now you don't need to share your firm's proprietary code with a third party. You could keep all your proprietary data on your own servers. You could also fine tune Code Llama to your own use cases potentially for as little as a few $100 if you use a parameter efficient fine tuning technique like the ones I covered back in episode number 674. And since you're listening to a data science podcast, there's a good chance that a Code Llama Python variant is the perfect starting point for you. Again, the request form link to gain access to the model weights is in the show notes at superdatascience.com/712. All right, that's it for today. To hear more about Llama 2, Code Llama, and other open source LLM projects from Meta, such as Toolformer and Galactica, check out the very next episode of this podcast, number 713, in which Dr. Thomas Sielom, the extraordinary research scientist at Meta leading all these world-leading projects, is our very special guest on the show. All right, please consider supporting this show by sharing, reviewing, or subscribing, but most importantly, just keep listening. Until next time, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science Podcast with you very soon.